Okay, good afternoon, students. So, in the last lecture, we have covered the module 3, that is design a basic campus and data center network, right? So, in that chapter, we have already studied what are the different consideration for enterprise campus designing, right? So, and also we have seen some sample enterprise campus design as well, right? So in that, how this particular hierarchical model or hierarchical network model can be used in the enterprise network, right? So for designing this particular campus design that we have discussed, right? Also we have seen that particular sample enterprise campus design as well, right? How it can be structured, and what are the different components which we are going to use in this particular campus design, right? So all these are we have already covered, and then we have also discussed about the data center design consideration, right? So what are the points, or what are the criteria they are already there, which we need to be checked while designing the data center designing, right? Also we have seen the sample data center design also, right? So with respect to the campus and the data center, we have covered in our last session, right? So in today's session, we will start with the chapter number 4, right? That is designing the remote connectivity. Okay, so from that, the first point is enterprise edge WAN network we are going to study from today, right? So in this we will go with the what is mean by the WAN, what are the different goals of it, what are the different objectives of this particular WAN network, right? Then how this particular WAN interconnections will be there with respect to our enterprise architecture, right? So we are already seen these our that all the function areas, right? So with respect to that, how this particular WAN model will be connected to all these particular different functional areas, right? That we will see. Then some traditional WAN technologies which are already existing and we are currently using in nowadays, right? So these are the some lease lines, circuit switch network, packet switch network, sales switch network, right? So all these things we will see. Then how these particular traditional WAN technologies, right? So if you compare the traditional WAN technologies with your OSI layer model, right? Then what are the different similarities, or what are the different layers which will be working on this particular WAN technologies, right? That we will see in this particular circuit packet and cell packet versus the OSI, open system interconnection model, right? Then we will see a different topologies which with respect to this our packet switch network, right? So star is there, full is there, partial mesh topology is there, right? So with respect to what are the different disadvantage of each of these topologies, right? So that we have come to know so which topology will be helpful for this particular packet switch network, right? Then the next section we will see this particular WAN transport technology, right? So there are a number of transport technologies nowadays we are going to use, right? But we don't know each and everything about each of these particular transport technologies, right? So we will have some list, right? So lease lines we can also call it as an TDM. ISDN is there, frame relay is there, right? So ATM, asynchronous transfer mode is there, MPLS is there, right? So in MPLS also we will see what are the different operations of this particular MPLS and what are the different services this particular MPLS will be providing to us, right? Then Metro Ethernet is there, DSL technologies, cable technologies, wireless techniques, right? Then SDM we will see, SDH we will see, right? The syndrome, optical network and syndrome digital hierarchy. Then DWDM we will see the dense wavelength division multiplexing, and the last one we will see the dark fiber, right? So all these are nothing but your WAN transport technologies that we are going to see. And the last we will discuss about this WAN transport technology pricing and contract consideration, right? For example, if you wanted to choose a very cost effective transport technologies, right? So then for that purpose you must know all these kind of the transport technology, their pros and cons and all, in which kind of the network all these things are helpful for your organization, right? So with respect to the pricing and also with respect to the some contract basis, we will see all these particular transport technologies in today's session. Okay, so we will start with our session. Okay, so first of all we will discuss about what is mean by the van, right, and what are the different goals and objectives of this particular land, right? So as you know that the van is we can describe it is nothing but the primary design objective, right? For whatever the switches you are going to use, whatever the links you are going to use, whatever the or relay information you are going to use in that particular van, right? So all these things will be provided by the van services, right? So not only that, but also if you see, whatever the network provider gives you, right? So it offers charge for it, right? So we can call it as a fee, we can call it as a tariff, whatever it is, right? So whatever the provided by that particular service provider, right? So you're going to pay something to that, right? So therefore this particular WAN communication, whatever we are calling it, right? So therefore we can call it as a service. Why? Because you need to pay for that, right? So we need to see in this particular our Cisco enterprise architecture, right? So how modularize we are going to do this particular enterprise network, right? And if you consider this all WAN connections, which we are just concentrating on the one module of that particular enterprise edge, right? And which are connected to your remote sites and all that things, right? So we will see how these particular WANs are also operates in between your enterprise edge and the different service provider edge, right? So whatever the modules we have seen in that particular enterprise edge, right? So how this particular WAN is interconnected with all these modules, right? That also we will see. Okay, so basically it having two primary goals, right? The first one is, if you see the service level agreements, right? So you know already the networks, so whatever the which carries the application information between the different computers, right? So whatever the application which are not available for the network users, right, that means the network is failed to achieve all the design objectives. For that we are doing, or we are able to create our network, right? So that whatever the organization which will be using all that kind of the services or kind of that particular network, right? For example, if you see organization defines the level of the services, right? For example, the bandwidth is there, the allowed latency, right? So whatever the latency they will require, then the packet loss is there or not, right? So how much loss will be the acceptable, right? And all that thing, right? So these are the acceptable for the application which we are running across the WAN, right? And the second one, if you think, that is nothing but the cost of the investment and the usage, right? So obviously the WAN design are always we can see with respect to the budget limitations, right? So whatever the budget you have with your organization, accordingly the WAN design, WAN transport technology you are going to select, right? And therefore it will be very critical to provide all the reliable services for the end user applications, right? With effective in terms of your cost also, and in terms of your time also, right? So there are some if you see the objectives of this particular WAN, right? So why this particular WAN can be designed, right? So for if you see a well designed WAN, right? So whatever the designing you are going to do with the WAN, right? So it must reflect all the goals and the policies and characteristics, aims, objectives of your particular organization, right? Because if you see, then and then only there is a point to design a well designed WAN, right? Because it must shows goals of your organization, your characteristics of your organization, right? So by seeing only the WAN designing, you are going to able to again you can find out the what are the different futuristic expansion your organization is going to do, right? with respect to the WAN transmit technologies and all that things, right? So how well you are going to design your WAN, that will be reflect your all the policies, all the goals of your organization, right? And then if you see whatever this WAN technology you are going to select, right, that must be sufficient for the current use, that must be that must also having some scope for the some future expansion also, right? So whatever the future application you are going to use, or any future requirements for your particular organization or your particular that particular application, right, that must be fulfilled by that particular WAN technology, right? And if you see in terms of the investment also, right, though it cost of the investment and the usage, all right, so whatever the usage by that particular end users, right, it must be within a limit of the budget, right? So that's why this particular WAN, which type of the WAN technology you are going to select, that is very crucial thing for this particular WAN part, right? So this is nothing but your the goals and the objectives of your WAN, right? Then we will have this particular WAN interconnections, right? So if you see, this is nothing but our enterprise network architecture, right? So we have already seen this particular diagram many times, right? So this is nothing but the enterprise campus model. These are nothing but the functional areas of your enterprise network, right? So if you see here the remote access, right, so here this is nothing but your WAN we can consider it as a WAN. And if you see this particular this particular arrows is connection in between this particular internet connectivity, that is nothing but the ISP network, right? So connectivity in between the enterprise site, right, across the your ISP network is there, right? So also if you see this particular connection in between this particular PSTN to the remote access, right? So PSTN is nothing but your the public switch telephone network, right? Public switch telephone network to your enterprise site, this particular remote access, there is a connectivity in between this, right? And also if you see, this is nothing but your enterprise edge module, right? So which having this particular ISP edge model, right? And the ISPs are connected to this particular remote access, right? And also the PSTN is interconnected with this particular remote access. So this is nothing but your the WAN, right? So WAN connection can be it can be a point to point, right, between the two locations or the different locations, right? So you can use frame relay or any MPLS network within that also for to provide connections in between these particular WAN interconnections, right? So but one issue for this particular WAN connection is what you can select an appropriate physical WAN technology, right? Because if you see, there are multiple WAN technologies are already available, right? So not only the traditional WAN technologies, right? So we are already seen in contents as well, right? So there are some traditional WAN technologies and there are different other WAN technologies also there, right? So that also you need to study for that, okay, for selecting a good one for your organization, right? So that you need to select, okay. So then we will see what are the different traditional WAN technologies are there and what are their objectives or what are their functionalities, right? For example, if you see this lease line, right? So first one is traditional WAN technology. We are going to see the lease line, right? So lease line also we have in our college lease line of your SEM-VII, right? SEM-VII is a service provider, right? Through that we are going to get the connection, internet connection, right? So this is nothing but your point to point connections, right, which will be we can reserve for the transmission, right? So whatever the career we can call as an establish the connection, right? So it can be gives you either by dedicating a physical wire, right, or it will be giving you by giving you dedicatedly a channel, right? So we can call it as an FDM or TDM, right? That is frequency division multiplexing or time division multiplexing, right? So these particular lease line connections usually gives you an asynchronous transmission, right? So based on your this particular point to point connections, right? So it will be gives you as and when the transmission is required, right? So that's why this particular lease line is one of the traditional WAN technology. And next one is your circuit switched network, right? So this is nothing but your the if you see this particular circuit switch network, right? So duration for this if you see the duration of this particular connections, right? And if you see, it will gives you a dedicated physical path, right, for a single connection between the two different kind of the network or two different kind of the end users, right? So if you see the example for this is for like the PSTN networks, right? That you have the telephone company that will be reserve a specific physical path for the number whenever you are going to dial, right, for that particular call duration, right? So during that call time, right, so during that phone call, right, no one else can use that particular physical line which will be involved, right? So you know already that BSNL network and all that things, right? So they are going to use that particular circuit switch network over that particular for voice phone service over the PSTN, right? So in that part of, and it is an if you see, it is an asynchronous serial communication, right? Or you can also call it as an ISDN, right? So asynchronous serial transmission it having, right? So in PSTN, in telephone company, you can see this type of the traditional WAN technology circuit switch network, right? Then we have next one is the packet switched and the cell switch network, right? So we can call it as an PVC or SVC, right? So packet switched or a permanent virtual circuits, right, or the switched virtual circuit we are going to use, right? So it will be a deliver packet for deliver packet among all the customer sites, right? So whenever the user share all the common carrier resources, right, or can be used a different path through that particular WAN, right? So that particular carrier which we are going to use, it will be on our own infrastructure, right? So it will be efficiently use all these leased point to point links, right? If I wanted to give one example for that, then the packet switch network can include that particular extra X.25 protocol, right? Then a frame relay it can be have in this particular packet switch and the cell switch network, right? And if you compare it with the lease line, right, so lease line and the circuit switch network, so whatever we have seen before, right, which will be offers use the dedicated bandwidth, right, that other user cannot take, right? While in if you see in this packet switch and the cell switch network, right, it traditionally offer more flexibility and it would be more efficiently than your circuit switch network, right? And if you see the this particular cell switch network, right, so it will be combined some aspect of this particular circuit switch network and some aspect of this particular packet switch network, right? It will be because of that it will produce low latency and the high throughput over the this particular all these three traditional WAN technologies, right? So that's why if you see all what are the different the question may be asked in your examination that write a short note on this particular traditional WAN technologies, or they can be ask you for the specific one, what is the or what is the difference in between these particular traditional WAN technologies, right? So you must know that whatever the lease line, whatever the circuit switch network which we are which both of the offers to their end user the bandwidth, right, which will users cannot be take, right? So in contrast, this particular packet switch which will be giving you more flexibility and use the network bandwidth for more efficiently rather than this particular circuit switch network, right? While this particular switching usually combine the aspect of the some of the aspect from the circuit switch network and some of the aspect from the packet switch network, right? And it will be produce the high throughput or low latency from this particular cell switch network, right? So that you need to understand. Okay, then we will see how this particular circuit level, packet switch level, cell switch networks, right? Which we are, if you are compare with this particular OSI layer model, right? So whatever we have studied, that 7 layers, right? So this particular circuit switch, if I am talking about this first one, the circuit switch network with respect to our OSI model, right? So it will be fitted into your first layer, that is nothing but your physical layer, right? Because if you know layer 1 OSI protocol describe method of binary encoding or physical transmission media, right? So whatever the PSTN networks we are going to use, right? So it will be used this analog method, right, to encode data on the phone line, right? So in that perspective, we are going to use this particular physical layer if you concern with this particular circuit switch technology, right? And also you know the function of modular and demodular, right, for that particular PSTN network, right? And also the ISDN networks too, right? So in that this particular circuit switched technology is we are going to use with respect to OSI model. It will be directly matched with your the physical layer, right? And if you see the packet switched and the cell switched networks, right? So it operates on the layer 2 of OSI layer, that is nothing but your data link layer, right? Because if you see there are some protocols are defined, right? So some methods are defined which we are controlling access to that particular physical layer, right? So it will allowing many conversation to multiplexing over the same physical transmission medium, right? And if you see by framing the binary transmission from at data link layer, right, and it will provide address to all identify endpoints within that particular data link, right? So for that part, this particular data link layer which will be helpful in this particular packet switch and the cell switched technologies, right, to create a physical path, right? Because if you see the virtual circuit, right, so it will be provide all the logical path in between the endpoints, right? So same way that the circuit switch will provide a physical path, right? So that you need to keep in mind. Okay, then we will see a different technologies or different topologies within that particular packet switch network. If you see, right, so here there are three topologies we have mentioned in under the packet switch network. The first one is the star topology. Already you know all these topologies with respect to the network, right? And already we have studied this as a prerequisite for this particular subject, right? So I'll just brief you once again, right? So this particular star topology is nothing but we can also call it as in hub and spoke topology, right? So whatever the features which will be provided this particular internet networking hub, right, that is nothing but the central router, right? So which will be provide access from the remote networks into the core router only, right? So whatever the communication is in between the remote network is possible through that particular core router only, right? So what is the advantage? Then it will be very simple simplified management for this particular star topology, right? And also it will be giving you the minimum cost, right? So it will be result from the low number of the circuits, right? But this particular star topology also having some of the disadvantage, that because of we are using a central router, right? That is nothing but the hub, right? So it will be a single point of failure for this particular star topology if we concern, right? Also because of that it will be not scalable when this particular star topology, right? Also if you are central router, whatever we are going to use as a hub, right, which will limits of the overall performance for access to centralized resources, right? Because whenever all the traffic which will be going to use to this particular centralized resources, right, or the other regional routers, right, so it will be going through only a single devices, right? So that's why it can be have a limit to that overall performance for that particular centralized router or centralized resources, right? So that's why this particular topology is also a not scalable one. Okay, so these are the some disadvantages over the star topology if you are concerned, right? Then the next one is your the full mesh topology, right? So in this each routing node, right? So each routing node is on that particular periphery, right, of a given packet switch network, uh, had direct path to every each node, right? So if you see in this diagram also, right, so each routing node have an periphery of a given packet switching network has direct path to each node, right? So every node is having a direct path, right? So provide we can call it as an any to any connectivity, right? So in any to any connectivity, right? So no, whatever the fully meshed environment you are going to create, right, so it will be provide you high level of redundancies, right? So because if you see in a star topology or fully meshed topology, right, so in a partial mesh topology, right, so this particular mesh topology is not all scalable, right, or large packet switch network, right? So some of the issues which having this particular full mesh topology is that whenever you are going to use the large number of virtual circuits, right, obviously it will be required by this particular fully meshed topology, right? So one for every connection in between the routers, right, the number of circuits is required, right? And how it will be and there is an some parameters for it to calculate all these things, right? So how many circuits are required and all that things, all that things, right? And the second problem is that the whatever the requirement for this particular large number of packet and broadcast replication, right? So these large number of packet and broadcast replication will be required which for the fully mesh topology, right? And if I wanted to comment on this configuration, right, so the configuration of the router is also very complex one in this particular thing, right, because you don't have any multicasting support over here, right, and you wanted to provide any to any connectivity in the fully mesh topology, right? So therefore the router's configuration will be more complex in that case, right? Then we will move towards this particular partially meshed topology, right? So if you see in partially meshed topology also, right, so it will be reduces within a region itself, right? So number of routers which you are going to use, right, so it will having a direct connection between the all other nodes, right, within that particular region itself, right? But if you see in this diagram also, right, so not all the nodes are connected to all other nodes, right? So there is not case like the fully mesh topology here, right? So some nodes are connected with the each others, right? So it must be send traffic through one for the fully connected routers over here, right? So this particular partial meshed approach whatever we are going to provide, right, so it is the best balance for this particular regional topologies, right? So if you are talking about the redundancy in terms of your performance or in terms of your number of virtual circuits, right, so this partially meshed topology is the best in this particular packet switch network topology if we concern, right? So these are the some network topologies with respect to the packet switch. Then we have some different WAN transport technologies, right? So I am just giving you some of the comparison chart over here, right? So with respect to the different technologies, so we have already seen this particular what we can call as traditional WAN technologies, right? So TDM, that is nothing but the lease line, then ISDN, then the frame relay, right? So these are nothing but the traditional WAN technologies, right? So other than these also we have some of the technology I have listed here, right? So with respect to the bandwidth, with respect to the latency, jitter, connection time will be required, then the cost, that is nothing but the tariff, and the initial cost for the setting up that particular technology, and the reliability of your network, right? So depending upon that I have just compared each and every WAN transport technology, right? So here the L is low, L means low, M means medium, and H means high, right? So that you need to keep in mind. So whatever the TDM, if you see with respect to the bandwidth, so it giving you a medium bandwidth, right? Low latency, low connection time will be required, the cost will be the medium, initial cost and reliability also the medium, right? So likewise I have mentioned here each and every transport technology over here, right? So if you wanted to select for your organization which technology or which van transport technology will be helpful, right? So according to the cost, according to the bandwidth, whatever you want for your organization, right? So depending upon this particular comparison chart, you can easily identify it, right? If so, for example I wanted to give, then if you see this particular wireless technology, right? So bandwidth for this particular wireless technology is low or medium, right? The latency and the jitter is so medium and high, the connecting time is very low, that we will be required, right? The tariff also low, that also we will require, right? The initial cost is a medium, right? Because of that particular routers and all that setup we will require for the initial, right? So that's why it is at a medium one. And the reliability also is low, that we obviously that we will don't want, right? So all but, and if you again see this particular dark fiber, right? For example, the bandwidth of dark fiber is high, right? The latency is low, that we want. The connect time is low, that also we want. But tariff is medium, and the initial cost of this particular dark fiber is very high, but also it giving you then the reliability, right? That is very high, right? So obviously all these parameters will be need to discuss among the organization, right? So which type of their budget is, right? So what is their requirement in terms of your bandwidth, jitter and all that reliability of your network, right? So depending upon that you can select any kind of the technology from the above table, right? Then we will see there are a different another all these van transport technologies, right? So we will see one by one what do you mean by this particular van technologies and how it is going to be used, right? So we will start with this particular TDM. Okay, so in this TDM if you see, right, so this is nothing but your the lease line itself, right? So it will be provide you, or it is nothing but the type of the digital multiplexing, right? We can call it as, which representing in bits, right? From if you consider the for two or more channels, if you are interleaved, right, on a timely basis, right? So instead of using a bandwidth, right, so we can use here the TDM. So the TDM indefinitely reserves all these particular point-to-point connection bandwidth for the transmission, right? So these are nothing but the channel-based transmission, right? So if you see the base channel for the bandwidth, which is nothing but the 64 kbps, right? So which we also known as a digital signal level, right? So this 64 kbps is the bandwidth required for that uncompressed digitized phone connection, right? So that's why this particular TDM, that is time digital multiplexing, we are going to use. That is nothing but the lease lines, right? So this is one because in this the TDM network we are dedicatedly providing one channel for that particular specific connection, right? That is 24, for example the 24 channels, each of 64 kbps, like that, right? So through that we will provide the end-to-end connectivity, right, of the 64-bit or end-to-end connectivity for that particular bandwidth transmission, right? So then the next one is the ISDN, right? So if you see in ISDN, we already discussed previously, right? So it is nothing but the digital phone connection, right? So it is available for communication since very long. It is a very old one, right? So this system ISDN, which allows you, right, so all the voice and the data both, right? So this ISDN provides you the voice and the data to be transmitted simultaneously. Okay, so both you can be transmitted simultaneously over the world, right? It gives you an end-to-end digital connectivity as well, right? So what are the different if you see there are different broadband technologies also there, right? Like that DSL, so that is the digital subscriber line, right? Then the public wireless, if you see, right? So in that also, if you see, nowadays there are IP security is there, VPN you are going to use, right? So ISDN gives you an effective solution for all these particular remote user application, right? So wherever so where the broadband technologies are not available, right? So this particular ISDN will use you nowadays. This particular VPN also you are going to use, the IPsec also you are going to use, right? So this particular public Wi-Fi and DSL cable is not going to provide all these functionalities to you, right? So to for the remote user applications, where this ISDN will gives you, right? So therefore these particular digital phone connections which will be media as a medium as a communication we are going to use, right? Then the next one is your the frame relay, right? So it is nothing but the example already we have seen as the example of your packet switch technology, right? Which we are using for connection in between the net devices on this particular WAN, right? So also it has been used from a very long time, right? So frame relay which will be used as an industry standard networking protocol, right? So which will be handles all the virtual circuits, right? So if you see the that HDLC, right, that is high level data link control, right? So encapsulation in between the connected devices, right? So all these kind of the thing this particular relay is going to handle, right? It also provides you the data connectivity over the PSTN, right? So using some of the analog modems you need to use for that, right? So it will be provide you the data connectivity as well, right? And then it will be also support for low speed connections, right? Or any if you compare that with the broadband technology, right? Then some that PVCs and SVCs, right? So which we are permanent and temporary connections, right? It will be created for data transfer and then it will be get terminated, right? So all these kind of the thing also this particular frame relay we are going to use. Okay, then this particular next one is asynchronous transfer mode, also we can call it as an ATM, right? So it will be processed asynchronously, queued and multiplex over the transmission path, right? So whatever the this particular asynchronous transfer mode cell which we are going to process asynchronously, right? So these are we can be multiplex over the all these particular transmission path whichever we are going to use, right? And this will also provide the support for this multiple quality of services, right? That is nothing but the QoS, right? To meet all these particular delay and the loss requirements whatever we have, right? In that case also this particular asynchronous transfer mode or ATM we are going to use. Okay, then we will see this particular MPLS, right? So what do you mean by this MPLS? So it is nothing but your IETF standard architecture. What do you mean by IETF? That is Internet Engineering Task Force, right? So is a standard, one of the standard for this particular architecture, right? So it will combines the advantage of your layer 3 routing with the benefit of the layer 2 switching, right? So layer 2 switching, layer 3 switching, multi switching you already know, right? So in that if you see in this particular architecture also, right, so it will be combines the advantage of the layer 3 routing with the benefits of your layer 2 switching, right? So this process this particular process which will be a result in a faster, more scalable and more flexible WAN solution, right? Because if you see in this particular MPLS standard now, it will evolve from the many companies, right? Including for example if you talking about the Cisco's, right? So it's also having its own MPLS standard, right? So it's having its own tag switching technology, right? So we can call it as a tag switching technology of Cisco, right? So it will be enables all the VPOs, end-to-end QoS, then the IPsec and all that things, right? So whatever we have discussed with respect to our this particular frame relay, right? So all these are also support to your MPLS also, right? Then we will see there are different MPLS services also we have. So for example, the traffic engineering, right? So if you see the this particular MPLS allows the traffic to be directed through a specific path, right? So whatever the specific path you are going to use in this particular MPLS, right? So it directly it might be different sometimes, at least cost path determined by the IP routing protocol, right? So whatever the routing protocol is defined the path, right? So it must be at some different path, it can't be a same path, right? So here is the MPLS having this particular ability, right, to define routes and resource utilization also. So that's why we are called it as under traffic engineering, right? Then the QoS support this particular MPLS also creates a connection oriented network, right, for IP traffic. Therefore it will be providing the QoS traffic controls, right? For example, if it might provide the guaranteed bandwidth to specific traffic between the two locations, right? So that is nothing but the QoS, right? So network reliability it is going to provide to you, right? Then the next one is the fast reroute, we can call it as FRR, right? So because FRR allows extremely quick recovery from the node or the link failure, right? So it will be prevent a different kind of the application from losing their own data, right? So that's why it will be use it as we can call it as a fast reroute, right? So it can be quick recovery from that particular failure of that node or the link, right? So it will be helps that particular application to crashing or to losing their own data, right? Then if you compare or if you see this particular MPLS and the VPN part, right? So VPNs are very much easier here to deploy on the these MPLS VPNs are very much easier for deploying this on the with respect to this traditional VPN, right? Because if you scale easily with the increasing number of routers and customers, right, and you are going to provide the same level of privacy whatever the layer 2 technologies is giving, right? So it will be very much useful with respect to this particular MPLS VPN. Okay, and the last one is the multi protocol support, right? So MPLS also can be used in your asynchronous transfer mode, that is on the ATM network, then frame relay network also, right? So in IP based internet also, right? So it having the SONET and Ethernet frames also, right? So it's having the support of multiple protocols, right? So in different transport technologies also you can be used this particular MPLS, right? Then we have different metro Ethernet, right? So service providers, right? So service provider can offer a metro Ethernet service, right? So deliver the voice, video and data networking. So metro Ethernet it will be provide you data optimized connectivity solution, right? So for your metropolitan area network or your wide area network, right? So based on this particular Ethernet technology, right, which we are going to deploy on an enterprise LAN, if you see, right? So because it will be gives you an high performance network, right, in a metropolitan area, that will be increase the need of the faster data speed, right, or the QoS requirements whatever they have, right? So all these things can be provided by this particular metro Ethernet, right? So it will be help you to deliver all this kind of the voice, video or data kind of the networking, right? So we can mainly use this particular metro Ethernet in the MAN and the WAN. Okay, so this is also one of the transport technology if you see. Then DSL technologies, right? So DSL will be gives you the high bandwidth over the or all the traditional telephone or the copper lines whatever we are used, right? So it will be work by the way of two modems at the either end of the wire, like for example the dial up or the cable or the wireless, right? So it will be a transmission technology, right, that enables service providers to deliver a wide variety of services for their customers, right? For example, if you see the premium or high speed internet or internet access, voice, VPN, video conferencing, and video on demand, right? So whatever the techniques or technologies you are going to nowadays seeing, right? So it can be provide you by the help of the DSL technologies, right? Because it will be gives you an high bandwidth over the telephone, over the this all or whatever we have already seen these traditional telephone copper lines and all that things, right? So if you compare with that, it will be gives you a high level of bandwidth, right? It will be gives you high speed internet and internet access, right? So that's why this particular DSL technology we are going to use. Then the next one is the cable technologies, right? So if you in cable technology, if you see it is a very good option, if you see in terms of the environments, right, where we can cable television is widely deployed nowadays, right? So this particular cable service also provides you the residential and the also provide for the residential and the commercial customers, right? So if you see in the universal broadband router, right, which can be also called it as we can call it as a cable modem, right, which will be provide you the high speed of the data connectivity, right? And it will be deployed on a cable company's head end, right? So if you see in this particular diagram also, right, so whatever this particular university broadband router, if you see, right, so it can be also called it as an cable modem of the termination system, that is CMDS, right? So it will provide high speed data connectivity and it will be deployed on this particular cable company's head end, right? And if you see the this universal broadband router forwards the data upstream to connect with the either PSTN or the network, right? So if you see here, this particular cable modem router is there, right? And this will be we are going to give you the remote access over here, right? So this particular is at the customer side offer, okay, and it will be gives you or support for transmission of voice, modem or fax calls, right, or the all this particular TCP cable, TCP IP cable, right? So this is nothing but your the cable technologies, if you see. Okay, then next one is the wireless thing, right? So wireless, we already know that nowadays wireless, if you see examples, right, the cellular phones we are having some pagers, if you see in a few decades before, then the GPS, then cordless, whatever we are going to use, then satellite television, right, wireless LAN we have, right? All these are nothing but some examples of this wireless one, right? So if you see the bridge wireless, right, so whatever we are going to design to connect two or more networks, right, which will be locating in different kind of the buildings, right, which will be gives you a high data rates for data intensive, right, and a series of wireless bridges or routers which we are going to connect, right, through a LAN or whatever it may be, through a LAN or through that particular satellite offices or some schools, some corporate campus, or any kind of the temporary networks, right? So for that purpose also this particular bridged wireless we can be called it as, right? So because it will be connect two or more networks typically, right? So which we are locating in the different kind of the building, we can call it as, right? So then again a next concept we have as a mobile wireless, right? So which will be includes all the phone, so cellular, voice and data applications, right? So this particular wireless technology which we are going to use, right, so it will be gives you all the digital services on the wireless itself, right? So if you see, there are some technologies on mobile wireless also, right? So for example, if you see, the first one is the GSM, right? That is nothing but the global system for the mobile, right? So it having some digital mobile radio standards, right? So it will be using some time division multiplexing technology, right? So it's having in a three bands, right? So 900, 1800 and 1900 megahertz, right? So on that particular different bands, it will be this particular GSM will be functions, right? And it will be uses for that the time division multiple access technology, that is the TDMA, right? So this is nothing but the radio standards if you are going to use, right? Then the next one is the general packet radio service, that is nothing but the GPRS, right? Which will be extends the capability of this particular GSM, right? And it will also support for the data transfer, right? So generally speed for that particular GPRS, which will be offered to our customer or to the clients, right? So this is nothing but the for 64 kbps to 128 kbps of ISDN speed it can be gives you, right? Then the third one is universal mobile telephone services. If you see, it's we can call it as a third generation, or we can call it as a 3G broadband, right? So it will be packet based transmission, right? So whatever the text, voice, video, multimedia, right, which you need to send or you need to transmit, right, within that particular packet based transmission, right? And data rate, if you see, it is up to the 2 mbps, right? So this particular UMTS, that is universal mobile telephone services, right, which will be offers consistent set of services, right, to your mobile to your mobile phone user or your mobile computer users, right? So it will not depending upon the location, right? So it will so whatever the location you have in the world, right, so it can be, we can use as an third generation as a 3G broadband service, right? The packet based transmission, on the basis of packet based transmission, right? Then the last one is the code division multiplex access, that is nothing but the CDMA, right? So it will be, obviously you all already know about this, it is nothing but the spectrum technology, right? So that will be assigned a code to each conversation, and to that particular individual conversation which we are going to encode it, right? So that will be a pseudo random digital sequence you are going to maintain, and from that the communication can be happen, right? So this is nothing but the code division multiplex action, right? So it is nothing but the spread spectrum technology, right? So what it does, it just code to each and every conversation, right? And that particular individual conversation can be encoded in that particular digital sequence, right? So this is nothing but the CDMA also, right? So these are some of the mobile wireless transport technologies, right, if you are concerned with the wireless technologies, right? Then if you see this particular WAN, WLAN, right? So there are on different bands, different speed it supports, right? For example, I have given no, I'm not given. So okay, so here if you see, you already heard about this particular IEEE 802.11 standard, right? So if that particular standard is 802.11a, right, then it will be provide you the 54 mbps, right, in 5 gigahertz band, right? If it is 802.11b standard, right, so it will be used on 11 mbps in 2.4 gigahertz band, right? And again, if you see, if you use 802.11g standard, right, so it will be used you 54 mbps in 2.4 gigahertz band, right? So this particular WLAN technology will be replaced all these particular traditional wire networks, right, whichever we are going to use, right? And it will be gives you the high range of the application, right, and the high level of security as well to do all the wireless devices, right? So if you see in this particular WLAN, right, so all these kind of the things we are going to use. Okay, then we will see this particular SONET, right, that is nothing but synchronous optimal network synchronization, or SDH, we can call it as a synchronous digital hierarchy, right? So this is nothing but the SONET, or we can call it as or SDH, right? So synchronous optimal network, that is SONET, and this SDH, that means synchronous digital hierarchy, right? So it is nothing but a circuit based bandwidth efficient technology, right? So if you see here, right, so it will be established high speed circuit, right? So using some TDM frames, right? So in right, so it will be based on this particular TDM, time division multiplexing frames, right? So it will be results in the guaranteed bandwidth, right? So whatever you are going to actual use, right? So common bit rates is also very high, right? So current maximum of 10 gigabits per second is the maximum speed for this particular SONET, right? So if you see in this particular optical carrier rate for digital hierarchy, right? So if you have some, it's having some of the standards, right? So if you see some of the standards which I am giving you with the speed, right? So if you see this particular OC, that is optical carrier 1, optical carrier 3, right? So it having some 51.85 mbps, 155.52 mbps and all that things, right? So these are nothing but we have a optical carrier for each and every this particular digital hierarchies, if you consider this particular SONET, right? Because these capabilities where the reliability of the network will be more, right? And it will be also cope up with all the system faults, right? So whatever there will be some link failure or whatever it may be, right? So because any kind of the link failure, the entire network can be collapsed, right? So for the single SONET or for a single SDH, right? So this particular network element does not lead to failure for the network, right? Because it having some ring kind of the structure, and which sends all the IP packets directly over the SONET frames, right? So whatever the SONET or SDI rings which we are going to see in this particular diagram, right? So here the two IP encapsulation for user interface can be done, right, with the help of some ATM or packet over this particular SONET or SDH, which will be send all the IP packets directly over SONET frames, right? So which will be gives you an more proactive performance monitoring, and automatic recovery will be take place in this particular automatic protection switching mechanism, which we are be going to use in this particular SONET or SDH, right? Then we have this DWDM, that is dense wavelength division multiplexing, right? So if you see in this diagram also, right, so it will be increases the bandwidth on an optical medium, right? So it will be very crucial component in optical networks, if you see, right? Because it maximizes the use of installed fiber cable, right, and also allows the new services to be provisioned efficiently over existing infrastructure, and that's why this particular DWDM will be used, that is dense wavelength division multiplexing, right? So whatever the open architecture system which will be allows the connection of the very variety of the devices, right, including if you include the ATM, then SONET, then IP routers. Okay, so this particular DWDM is also used inside that particular SONET rings, right? So whatever we have seen in this particular diagram, right? So here itself also we are going to use this particular DWDM, right? So it will be useful for increase the bandwidth of an optical medium, right? Then we have the last one as an dark fiber, right? So if you see in the dark fiber, which will be provided by all the company's devices and does not have this particular SONET or SDH whatever we have seen, right? It will be the dark fiber connection eliminates the need of this particular SONET multiplexers, right? So which will be required in this particular SONET rings, right? the edge devices which we are connect directly over this particular site to site dark fiber, right? So if you are using this particular layer 2 encapsulation, for example the gigabit ethernet, right, then this connectivity is used for the transmission of the data over the long distances, right? So where you can use this particular DWDM, right? Okay, so this is nothing but the dark fiber. Okay, and the last one, that WAN transport technology pricing and this contract consideration, right? So if you see, we are discuss among all the various transport technologies, right? And you need to select over the pricing, right? So what are the different pricing for each and every transport technologies, and what are the distance in between by which you need to connect it with your end devices, right? Or you need to use it your organization, right? So in that you need to again think upon the pricing and their contract consideration also, right? So in terms of the contract also, you need to think upon how they are going to provide you for the period of, for example, the 20 years, 10 years, 5 years, right? So you must do the long term contract. So it will be if you do the long term contract, then it will be reduces your cost also, right? So obviously it is the way for each and every whatever the contract you are going to do, right? And in that also, that particular service level agreement is also the very important aspect, or a very important point, that you if you are going to provide, or if you are going to use some of the technology from that particular service providers, right, then the service level agreement is will be helpful for you to, if you are having any kind of the problem in the future with respect to that particular technology, right? So all these things you need to keep in mind while by choosing the WAN transport technologies, right? So so in this today's session, what we have covered, that there are different goals and objectives of WAN, right? Then how this particular WAN are interconnected with our enterprise network, whatever we have seen in our edge model, right? Then there are a different traditional WAN technology, lease line, circuit switch, packet switch, cell switch networks, right? And how all these traditional WAN technologies are we can if you are compare with this OSI layer model, right? So how it can be represented, right? So by using physical layer, you are just with the circuit layer, right? And if you are going to use the packet and cell, then the data link layer it will be working with, right? So in that also we have seen a different topology. In that also the partial mesh topology is a good one if you are comparing the star and the full mesh topology, right? Then we also discussed the different WAN transport technologies whatever we have, like TDM, ISDN, frame relays, ATM, that is synchronous mode, MPLS, its operation and services, metro ethernet, DSL, cable, wireless, right? Then SONET and SDH also we have covered. Then DWDM also we have seen, and the last one we have seen, that is dark fiber, right? And lastly we have discussed about the pricing and the contract consideration, right? So if you are done the contract in for the longer period of time, then it will be also reduces your cost, right? And whatever the organizational requirement and distances in between the internetworking devices and all that things, right? So depending upon that, you need to select all these particular WAN transport technologies for your organization, right? So that's it for today. So there is one test, you just go with this particular link, ma'am will send a link in the chat box. Okay, thank you. We will stop today. Thank you.